So by now you should be really familiar with the concept of functions and how they behave. And you can see here I've got my classic little function box here. And we understand that the idea of a function is that it works with inputs. So we have inputs on the left here. And I input a number, and then out comes a number that is created or fashioned or calculated by the rule. Actually, I'll make it a bit more, or I'll make a really obvious one like that. So there's a rule there. In comes 1, out goes 1. Here comes another one, in comes 2, and then out comes 4. In comes a quarter, out goes a 16th. In goes -2, out comes 4 as well. Feel free to pause the video and figure out exactly what this rule might be. Okay, did you have a crack at doing that? Did you see that this is the rule f of x equals x squared? So when we use something like f of x, we're saying take the input, apply the rule, and that's what the output is. The rule gives us the output. So x squared is the rule, but it's also, when we substitute a value in, the result is the rule. So the input is 1, the output is 1 squared, which is 1. The input is 2, the output is 2 squared, which is 4, etc. Okay, these are the things that you should be familiar with. So in this video, we're going to have a look a little bit about language around the ideas of inputs and outputs and functions, because it's important to get a broad idea about what these things, so that you can apply them to lots of different functions. And banal reason is because you'll be tested on it, but it's more than that. It's also because you will be, it's an important concept to get across. So I'm going to start by just talking about this group here. Now, this is just a small group, and then I'm going to talk about this group here as well. Now, this group that I've circled on the left here to start with is what we call a set of numbers. Now, I've only just chosen a few numbers here, but in fact, this function will take in any old number, and it will output not any old number, it will only output certain numbers. What would those numbers be? Did you think any old number? That's not right. Did you think whole numbers? You can see that's not right. Did you think positive numbers? That's nearly right. If you said anything that's not negative, that would be right. Okay, so we have this idea that we can describe a function, well, not fully, but you can describe the inputs of a function, and you can describe the outputs of a function. And because this is a common thing to do, we stick a name on it so we can start referring to it rather than this is the set of inputs and this is the set of outputs. So when it comes to the set of inputs, we call that the domain of a function. So the domain is equal to the set of inputs. And this here is the set of outputs, and the official word, I'll just color code it so it's all the same, is called the range. Okay, so the range is the set of outputs. So the critical thing as far as you're concerned is that you need to be familiar with those two words. It's just a language warning that if it says what is the domain of the function, you're asked to describe what the set of inputs are. And if you're asked what is the range of a function, you're asked to describe what the set of outputs are. And we've got a way of describing it in a pretty precise way. And we're going to have a look at this next, and then I'm going to finish the video. And in the next video, we'll have a look at some examples of that. So I'll slide over here, and I've got a little aid to memory, a mnemonic, to help you remember what domain and range is all about. And the mnemonic is simply Dixroy, which sounds more amusing than it really is. So Dixroy stands for this. The domain, D, is the set of inputs, I, and usually for an XY graph is the X coordinate. Could be if it's a time graph, then it might be T, but you don't want to say Dixroy. X is the usual, right? So Dix, and then Roy is the other one. The range is the output, is a set of outputs, is the Y coordinate normally. And you can see here down below here, I've got a bit of notation for you that you might see. You'll probably never, not in 315, in 415, yes, but in 315, you might read it, but you'll never have to write it, I don't think. And you write that the function is defined as going from the domain to the range. So F colon D arrow R. And the D and the R here is an actual description of the domain and the range, which we'll get to in a moment. And the way it works in table format is that you've got the I, the X, the domain is like a list of values here in the table, and the O, the Y, the Y values would be the Y outputs, okay? And then we often write them as a set of ordered pairs, right? X, comma, Y. X being the input, Y being the resultant output. And we often hear words like independent being the X coordinate. So the independent variable is associated with a domain, and the dependent, because it depends on what the value of X is often the Y coordinate. So these are the kinds of things that kind of get bandied about a lot. Now, let's put a pin on that. I'm going to zoom all the way out, and you can see some stuff we're going to get into in a second. But I'm going to look at slide 3 here, a relation versus a function. And this is just, again, a little bit of language that you need to be aware of. As you can see here, as I've written here, a function is a special type of relation. So a relation is basically a set of inputs and outputs. So a function is a relation. Okay, so if you take a set of inputs and you get a set of outputs, that's called a relation based upon a certain rule. And I can write a rule that will give me a set of input for a set of inputs. I get a set of outputs. That's not a function. But what makes a function special is that for any input, there's only one output. Okay, so when we're looking at the domain, all the values in the domain, each value in the domain only maps to one value in the range. Okay, so the easiest thing to do is to apply the vertical line test to a relation to see whether it's a function or not. Now, if you have a look here on the two examples I've got, this is a rule. I can write a rule that will describe this graph. You can do it in Desmos. You can go x squared plus y squared equals 4, and you will get a circle like this, right? So you can definitely write a rule which will give me this circle on a set of graphs. But if I just pick, and a circle's like the perfect example, really, because there's so many of them. But I'm just going to pick a point at random in this instance. And I go down here. Now, if you remember that a graph is inputs along the x-axis and outputs along the y-axis, then if I pick a point here and I can go up to a point on the graph, but also down to a point on the graph, then that means that for this input, there are two possible outputs. I don't know what it is, don't care what it is. The important thing is that for this input, there are two possible outputs. That means it's a relation, but not a function. Okay? Now, it only needs to fail at once somewhere for it to be a relation, but not a function. Okay, now if we have a look at the other side of the other graph here, it doesn't matter where I go along the x-axis, anywhere along here, if I pick a point and go up and go down, then it only hits once. Okay, so this means it is not only a relation, but it's a function. There we go. So that's the critical points for this video. I'll start a new video up when we have a look at domain and range notation. That'll be slide 4 down the bottom there. But let's just pick up on the key points and I'll finish off. So a function or a relation really is a set of inputs that gets applied to a rule, and then we get a set of outputs. The set of inputs is called the domain of the function. The set of outputs is called the range of the function. You can think of it as Dixroy, domain input x coordinate, range output y coordinate. And we can talk about a general concept of relations as being any old rule, but a function is a particular relation where for every input there is only one output. It can be the same output, but for more than one input, but there can only be one output. Oh my gosh, that was really confusing. I'll say that again, but I'm not going to start the video up, sorry. If I have a function like this, then this input is here, and this input is here. So the output is the same, but it's still a function. So the only time it fails it is using the vertical line test, where you can see that for the single input, there are two possible outputs, and therefore it's a relation, but not a function. Okay, see you next video.